Hello and welcome to the live stream here at o'kellychemistry.com. I'm Ivana O'Kelly and thank you so much for joining me this evening. In this live stream we're going to start off with a review of how to do significant figures. Then that will lead us into different measurements that we take in the chemistry lab, and we'll follow that up with a demonstration and some calculations as they relate to density. So ladies and gentlemen, I am about to start and I hope you have a pen and paper ready. If you do have any questions during this live stream, I encourage you to go ahead and enter them into the chat. I will have some checkpoints along the way for you. These will be interactive quizzes accessed directly here through the course at o'kellychemistry.com. Ladies and gentlemen, let's get started. So I'd like to start off with a question for you. And the question is, how comfortable on a scale of 1 to 10 are you with significant figures? So 1 is not very comfortable and 10 is very comfortable. Okay, so we have a couple of 3s, a couple of 4s, someone's at a 7. Okay, great. We'll see if we can get you to that 10. So, significant rules, what are they? Here I have the 3 big rules as they relate to significant figures. So, the first is that non-zero digits are always significant. So that will be numbers 1 through 9. Our second one, any zero that is found between 2 significant digits, they are also significant. And our third rule is that a final zero or a trailing zero in a decimal portion of a number are always significant. So here we have a number, and we're going to break it down in terms of the different parts of the number. So at the beginning, we can see that we have our leading zeros in blue, so at the beginning. Our non-zero digits are in green, 1 through 9. Our captive zero is going to be a zero that is found in between 2 non-zero digits, and a trailing zero is found at the end of the number. So just like a crock of gold found at the end of the rainbow, it's lucky. This trailing zero is also lucky, therefore you have to include it when you have a number with a decimal point. So what I'm going to do is I'm going to look at numbers in terms of if the decimal point is present, and then we'll look at numbers where the decimal point is not present and how that corresponds to significant figures. So here's our number again, and when the decimal is present, we're going to count the first non-zero digit on the left, and then we'll count all the digits to the right because they will be significant. So our first number that we're going to count is the 2, then the 0, the 3, the 5, and lastly our trailing zero is going to count because the decimal point is present. So we can see that we have a total of 5 sig figs. Sig figs will be the shorthand for significant figures. So let's go ahead and try some. Again, our rule is here on the right hand side, so we have our first non-zero digit on the left. So in our first number that will be 3, and every digit after that is going to count, so those zeros will count. In our next number we underline the 6, the 5, the 0 and the 0, giving us a total of 4 significant figures. In our third number, our first non-zero digit is a 5, so that means in this number we only have 1 sig fig. In our next number, 0.1256, we start with the 1, the 2, the 5 and the 6, giving us a total of 4 sig figs. In our next one, we have 2.3689, so all of those numbers are going to be significant. So we'll underline them, 1, 2, 3, 4, 5. Next number, 1508, so that's a captive zero, it's going to count, giving us a total of 4. And in our last number, we have a 4 and a 0, and because that decimal point is present, that trailing zero is going to count. Okay, let's move over to what happens when the decimal point is absent. So when the decimal point is absent, we're going to actually go in reverse. So we're going to underline the first non-zero digit, and we're going to go in reverse. So we have the 5, the 3, the 0, and the 4. So that means that we have a total of 4 sig figs in this number. There is no decimal point, so therefore your trailing zero does not count. So you can put an X through that if you want to. So here we have a list of numbers, and again, all of these numbers, there is no decimal point present. The decimal point is absent. So our rule, we are underlining the first non-zero digit on the right-hand side of the number, and then we're counting to the left. So in our first one, we have 3. So that means that we have one significant figure. Next number, I'm going to underline the 5, and I'm going to do an arrow just to remind us that we're reading it backwards. So that gives us 2. Next one, we're underlining the 5 and the 5, giving us 2. In the next number, we have all these zeros. They are not going to count because there's no decimal point present. So we are reading in reverse, giving us 1. In our next number, we'll start with the 1, the 2, the 0, and the 6. That gives us a total of 4 significant digits. Next number, we'll start with the 1, 2, 3, 4, 5, 6. That means that we have 6 significant figures in this number. And number 4 gives us 1. So this is our rule when we have a number that there is no decimal point present. So we underline the first non-zero digit on the right-hand side, and we count all the digits to the left. So in chemistry, we'll also deal with numbers written in scientific notation. So we have to be able to determine how many significant figures are in it. Easiest way is just look at the decimal portion, but just to show you what this number would look like if I wrote it out expanded, it would be 588 with 21 zeros. So let's go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, and 21. So again, the decimal point is absent, so we're underlining the last digit on the right, and we're counting in reverse. So that means the 8, and the 5 are going to count, so we have 3 significant figures. But just look at the decimal portion of the scientific notation, and that tells you how many significant figures you have. So here I have a mixture of numbers that I'd like us to try. And I'm also going to pull up the 2 different rules. So on the left-hand side, the decimal point is present. On the right-hand side, the rule here is for when the decimal point is absent. So one thing that I'm going to do is I'm going to do everything with the decimal absent first, and then I'm going to go back and do the numbers that have the decimal point present. So our first one does not have a decimal point present. So we know that we're reading backwards, so it'll have 3. This one will have 4. This one will have 3. I'm going to skip the next and move over to the right-hand side, and I see 3050. So that will give me a total of 3 significant figures. So they're all my numbers that do not contain a decimal. So we'll now switch over to what happens when we do have a decimal point present. So the rule for that is we underline the first non-zero digit, and everything to the right is going to count. So here we have 3. Our next number, there's underlining the 1, 2, 3, and 4. In this last number in this column, I have 1, 2, 3, 4, 5, 6, 7. So I have 7 digits that are going to count. Moving over to the right-hand side, start with the 4, the 3, and the 0, giving me 3 significant figures. Next number, I'm underlining the 3, 2, 3, 4, 5, 6. I'm just going to count them out versus actually saying the numbers. And then in our last one here, we start with the 3, 2, 3, 4, 5, 6. So it's a good idea to underline the digits that count. I like to put the arrow in, and in time you don't end up having to do the arrow, but if you're learning this, the more that you can talk to your text, the more that you can identify what the pattern is and repeat it, the greater the success of you'll be remembering this content. Okie dokie, let's move on. So in terms of calculations, and we'll be doing some calculations with significant figures in a minute, is any number that is counted is an exact number and it has unlimited significant digits. It will not be involved in determining the sig figs in your final answer. So that's very important. So I have a dozen eggs here, so 1 dozen is equal to 12 eggs. 1 mile is equal to 1.609 kilometers. And here's a $100 bill. So one $100 bill is equal to $100. Okay? So in summary, here's our first number that we had. So identify the leading zeros. They're going to be at the beginning. Our non-zero digits are 1 through 9. Our captive zeros, sometimes they're referred to as they are sandwiched in between the non-zero digits. And then your trading zeros, they're going to be at the end of a number. And again, watch out for that decimal point. That's when your trading zeros are going to count. On the right-hand side, here's a chart I made in terms of decimals being present or decimals being absent. So if the decimal is present, we're going to read it from right to the right. And if the decimal is absent, we are reading it in reverse from the first non-zero digit. So underlining a couple of them here, that'll help us remember. Okay. So what I'd like you to do now is go to the Math and Chemistry 1 course, and there is a quiz on identifying the correct number of significant figures in each number. And once we have finished that, then we're going to move on to doing calculations with significant figures. So let's try some calculations as they relate to significant figures. On the left-hand side here, I have the two rules. So multiplication and division, our answer will be based on the least number of significant figures that is given in the question. When we're looking at addition and subtraction, we're going to base it on the least number of decimal places that's given in our calculation. So this first number, we're given 100.1 plus 4.89. We're going to go ahead and put that into the calculator. Before we do that though, it's a good idea, we're going to identify what rule it is. So it's dealing with addition and subtraction. So I need the least number of decimal places. Well, 100.1 has 1 decimal place and 4.89 has 2 decimal places. So I know in my answer, I can only have 1 decimal place. So let's go ahead and get the calculator set up. So we're going to go ahead and put in 100.1 and we're going to add 4.89. And we can see the display is 104.99. So it's a good idea that you're able to separate the display in the calculator from your final answer. The calculator is not calibrated for significant figure rules. Sometimes it is and you might get lucky, but we have to apply the rule once we see the number displayed on the calculator. So our final answer, we know that we can only have 1 decimal place. So therefore our final answer is going to be, we're also going to have to round it. So our final answer is going to be 105.0 because the 9 is going to round up and make the 4 a 5. But we have to put 1 decimal point in our answer. Okay, so here's another one. We have 52 times 5. So 52 has 2 significant figures. 5 has 1 significant figure. The rule that we're using is multiplication and division. So my final answer can only have 1 significant figure. So when you put 52 times 5 into your calculator, you're going to get 260. So 260, that is how many significant figures? Well, underlining the 6 and the 2, that is 2 sig figs. So my final answer can only have 1 significant figure. So I'm going to have to take my 260 and round it to 300. And there I have 1 significant figure. There's no decimal point. It's just 300. All right, this next number, our calculation, 84 divided by 72. So we're still focusing on our least number of significant figures. So we know that both of these have 2 sig figs, so we'll write down 2SF into our calculator, 84 divided by 72. And that's going to give us 1.11666 recurring. So my final answer can only have 2 sig figs, so that will be 1.2. The 6 will make a 1, a 2. So what do? We made sure we knew what our rule was. We identified our number of sig figs. They both had the same number. So my final answer also has 2 significant figures. So this next one, I have 8.00 minus 0.3. So this is going to be the least number of decimal places. So that's going to be this one. There is 1 decimal place. So my final answer can only have 1 decimal place. So let's go ahead and get this in the calculator. 8.00 minus 0.3. Might need a calculator for that, but we get 7.7. My final answer, I have to have 1 decimal place. This time, this is an example. I wanted to do one where you could see the calculator actually gave you the correct number of sig figs. Again, that's not always going to be the case. So you have to make sure that you know what these rules are. Generally, they are implied. The question will not say to the correct number of significant figures. You have to know what these rules are. They'll be with you all the way through your semester in chemistry. So please go ahead and click back into the course for the quiz. And this time the quizzes will be on the significant figures in terms of calculations. So make sure that if you are multiplying or dividing, it's the least number of significant figures. If you are adding or subtracting, you're basing it on the least number of decimal places that's given in the question. So I'll give you a couple of minutes to do that. Okay, so now that you've finished those calculations, if you would be so kind as let me know how comfortable are you now with significant figures. So on a scale of 1 to 10, 10 being the most comfortable, 1 being the least comfortable, go ahead and enter that into the chat box for me. Fantastic. We're seeing some 7s, 8s, 9s. Ooh, we even got an 11 in there. Wonderful. Okay, well now that we've covered the basics on significant figures, we're going to transition into measurements and how they relate to, and how significant figures relate to measurements in the chemistry lab. So when we're carrying out a measurement, obviously we have to use a tool, and the tools that we're going to use are going to impact how precise we are with our measurement. So let's recap here on accuracy versus precision. So I'm going to call this A, I'm going to call this B, and I'm going to call this C. So on the dartboard A, we see that there are 3 darts dead center in the bullseye, and they're all close to each other. This would be an example of something being accurate and also being precise. Accurate in that you hit the bullseye, precise in that they're close enough, very close to each other. On dartboard B, the 3 dots are up here, and those 3 dots are close to each other, so that tells me there is precision. And then in terms of accuracy, they are not close to the bullseye, so therefore it is not accurate. On dartboard C, we have 3 different darts landed all over the place, so they would be not accurate and not precise. The first one, maybe we'll call that beginner's luck. Okay, so here I have a line and I want to figure out what is the length of this line. Well, what would I use to measure the length of the line? So tell me what would be the instrument that I would use. Go ahead and type it in there to the chat. Nice, ruler. Okay, well here I have a ruler. So I'm going to grab my magnifying glass here and we're going to zoom in and we're going to say, well, what is the actual length of this line? So when we're making a measurement in terms of length, I am certain that it's greater than 11. I know that it's less than 12, but my ruler doesn't have any markings to tell me, well, where exactly does it fall between 11 and 12? So therefore, I have to make an estimate as to where the actual line falls between 11 and 12. So let's go ahead and enter what is your estimate into the chat in terms of it falling between 11 and 12. Okay, we got 11.4, we got 11.5, we got another 11.5. So when we're making measurements with a ruler, our last number is going to be an estimated digit. So for each of these, the 4 in this one, the 5 in this one, and the 5 in the last one, I'll put in the unit here, centimeters, that represents the estimated digit. So when you're measuring length, you have to always include an estimated digit. Now let's connect this to significant figures. Each of these are going to have 3 sig figs. Now here's my same line, but this time I have a ruler that has millimeter markings on it. So 10 millimeters is equal to 1 centimeter. And 100 centimeters is equal to 1 meter. So let's grab my magnifying glass here. And if we go in, zoom in, we see that the end of the line is actually dead on 11.4. So if I wanted to write down what the actual length of that was, it's going to be 11.4. And my estimated digit, because it's directly on the line, I'm going to include a 0. And my unit is centimeters. So here I have got 4 significant figures. So I can be more precise with this ruler than I was with the last one based on how it's actually graduated. So that's going to be very important when you're recording your data. Here's another line. So here is my ruler that just had the centimeters on it. So the length of this line, if I zoom in, seems to be closer to 11 than 10, so it's definitely over the halfway mark. So let's see what we would estimate for that. So we know it's definitely greater than 10, and the 8 is going to be my estimated digit. My unit is centimeters, and I have a total of 3 significant figures. 3 sig figs. So now here's our same green line, but this time I've pulled out the ruler that has millimeter markings on it. So zoom into this, and you can see it's greater than 10, it's greater than 10.5, 11, 10.5, 0.6, 0.7, 0.8, somewhere between 0.8 and 0.5, or 0.9. So that would give that 10.85 centimeters. This time I have 4 significant figures. So when you use this ruler, you're going to have a greater number of significant figures. All right, we're going to transition into volume. So here I have a collection of flowers that are found in different glassware that we use in the chemistry lab. So obviously we're not going to be able to use these, but I thought they look pretty. So here is a beaker and I want to estimate what is the volume. I want to take a measurement. What's the volume of this? Well, I can know for certain it's somewhere between 20 and 30. So I'm going to estimate it's 25 milliliters. So again, I have 2 sig figs. So every time you look at a number in chemistry, you should automatically train yourself to go say, well, how many significant figures are present? Here I have a graduated cylinder. So the smallest division on this is a milliliter. And if I zoom in, I know that this is going to be 30, 31, 32. The meniscus, which is going to be the bottom, it's slightly under 33. So my volume, I would estimate, is 33.9 millimeters. Change that up, 32.9 milliliters. It was just under 33. And the number of sig figs are 3 sig figs. So that's for volume. Another type of measurement you make in chemistry is you're using a thermometer to measure temperature. So on the left-hand side, I have my thermometer. I placed it into a beaker of room temperature water. Came out at 22.5 degrees Celsius. So the 0.5 is going to be your estimated digit. Now it is 2021, so not all our measurements are made with thermometers. We do have digital devices that we use for, or thermometers that we use for our temperature. So if you are using a digital probe for temperature, whatever number is displayed, that's the number that you write down. You do not need to include an estimated digit when you're using a digital device. So there are no estimated digits when using a digital device or instrument. I'll put down instrument. So our thermometer temperature here is 68 degrees Fahrenheit. So that has a total of 2 sig figs. When we're talking about temperature, we have to talk about conversions. So we have to talk between Fahrenheit and Celsius and Kelvin. I'm not going to cover it in this live stream, but it will be coming up in a future live stream. In terms of mass, again, where I have 2 scales here, the one on the left is to 0.0, the one on the right is 0.00. So we're just recording when we want to find the mass, and I'm going to do one in a couple of minutes. We'll just write down the mass that's given on the actual display. So we see that piece of copper that I had on the left-hand side, I got 11.1. So that is a total of 3 sig figs. On the right-hand side, I have 11.13, and that's going to give me a total of 4 sig figs. So the scale on the right-hand side is going to give me more precision. And to finish up this section of the live stream, I want to go through the base units for System International. So all the different measurements that we make, what are our base units according to System International, also called SI. So for length, it's going to be the meter. For mass, it's going to be the kilogram. What I see students mix this up is when we do our metric conversions, our base unit there is a gram, but the SI unit for mass is actually the kilogram. Our electric current is amps. Our temperature is in Kelvin. We generally make our measurements in degrees Celsius using our thermometer. The amount of a substance is measured in a mole. Luminous intensity is measured by candelas. Our time is measured in seconds. So I'd like you to now go ahead and take another short little check for understanding quiz. Again, it's just a couple of questions on different types of measurements and SI base units. So go ahead and do that, and I'm going to set up for some density calculations. So now that you've taken the check for understanding quiz for measurements as they relate to significant figures and the SI base units, we're going to transition into the last part of our live stream, which is density calculations. So what is density? Density is the mass per unit volume. The units are grams per centimeters cubed. And the formula is density is equal to mass over volume. So let me introduce you to Mole Man if you haven't met him already, but he's my sidekick here. And he has two items that he would like to find the density of. The first one is an iron nail. Well, we think it's iron. He told me it was iron. It's got special powers, but only I can hear them. And then he has a piece of brass. So we want to figure out, well, what is the density of each of these items? Thing to keep in mind is that density is an intensive property. So intensive property, it's a physical property of matter. It means that no matter if I have a large amount of density or a small amount of a substance, the density is going to be the same because it's a ratio of the mass divided by the volume. So the first one we're going to start off with is we're going to find the density of a regular solid, and that one would be the piece of brass. So let me go ahead and zoom into my scale here. And here's my brass. And I'm going to put it onto the scale. And we see that it has a mass of 8.70. So let me go ahead and write that down on the board. Now I've zoomed into a graduated cylinder. And in the graduated cylinder, I'm going to be using that for my iron nail. So let me move it back to number here. So we found our mass of our piece of brass, and we saw that it's 8.70 grams. So I'll go ahead and write that on the board. The next thing I want to do is I want to find the volume of this piece of brass. So how am I going to find the volume? Well, it's a regular substance, so the volume will be the length times the width times the height. So I have a ruler here, and you can see that each side of the ruler is 10 millimeters or 1 centimeter. So let's go ahead and write that up on our board here. So the volume is 1.00 centimeters times 1.00 centimeters times 1.00 centimeters. So when I multiply those three together, I'm going to end up with 1. So that's equal to 1 centimeter cubed. So to find my density, it's going to be my mass, 8.70 grams. And I'm going to divide that by 1.00 centimeters cubed. In my final answer, I'm doing a division here. So when we're doing division, we're going by the least number of sig figs. They both have the same number. They both have 3 significant figures. So 8.70 divided by 1.00 is going to be, don't need a calculator, you got it, 8.70 grams per centimeter cubed. So mole man, that is the density of brass. Now, what is the actual density of brass? Do we know what the density of brass is? So here I have on the scale on my screen, I have the density of brass. So the density of brass is 8.40 grams. We calculated it out to be 8.70. So there may be other metals that are involved. So to me, it's close enough, but it's not pure brass, because pure brass has a density of 8.40 grams per centimeter cubed. So the next item that we're going to look at is our iron nail. So mole man wants to find out what is the density of our iron nail. Now, to find the mass of it is going to be pretty easy. I can use my scale, but to find its volume, it's not a regular solid, so I can't use my ruler. So I'm going to have to use something that's called water displacement. So I have a graduated cylinder here. You saw it a few minutes ago. I'm going to take the nail and we're going to drop it into the volume into our graduated cylinder. And the difference between the two volumes is going to equal the volume of the nail. And then we'll divide that number into our mass of our nail, and that's going to give us our density of our nail. So let me go ahead and clean off the board. This time we're not doing a regular solid, we're going to do an irregular solid. So it's an irregular solid, IRR. Let's add that in there. Our mass and our volume is going to be VF, our final volume, minus our initial volume. So that's going to give us our volume value. So let's go ahead and measure the mass of it. So there's the nail. I'm putting it on the scale. I promise this is not a poetry class. So 6.75. So we'll go ahead and write that down. The mass is 6.75 grams. Now to find the volume, there we go. We have to record our initial volume of our graduated cylinder. So this is water that I have dyed green just so that you can see it easier. So we see that the initial volume is 8.8. So our initial volume is 8.8 milliliters. And our final volume, I'm taking my nail, and I'm going to very gently place it in here. I tried this before and I lost some water. Then I had to start all over again. There it is. So what is our new volume? So 9.6 milliliters. So the difference of these two, so 9.6 minus our 8.8 is going to give us, let's put that in our calculator. So 9.6 minus 8.8 is going to give us 0.8 mils. So to calculate our density of an irregular solid, which we said was a nail, Mole Man told me that it was iron, Fe. So let's see if it is or not. So our mass was 6.75 grams. Our volume is 0.8 milliliters. So putting that into our calculator. Now, with our measurement of our volume, it should be 0.80 milliliters. 0.80 ml. So into our calculator, we'll put our 6.75 and we will divide that by 0.8. And that gives us 8.4375. So 8.4375, that's what's on the calculator. Sig fig wise, I need to have two significant figures. So that's going to be 8.4 grams per, and this time milliliter. Now remember that 1 milliliter is equal to 1 centimeter cubed. So move to my chart with iron. So 7.8 and 7.8 we got 8.4 grams per mil. And remember that 1 milliliter is the same as 1 centimeter cubed. They're used interchangeably. If it's irregular, you're using volume, water displacement, so that's why we have milliliters. When we had regular, we're using centimeters cubed. So this is regular, and this is irregular. So I think Moleman has been duped. 8.4 versus 7.8. So no, I do not think that this nail is made of iron. Okay, so let's move on, and I have some word problems as they relate to density. So our first one here, what is the density of carbon dioxide gas if 26.5 grams occupies a volume of 13.38? So I don't know what my density is. Let's change up that color. I don't know what my density is. My mass is 26.5 grams. My volume is 13.38 milliliters. So density is equal to mass divided by volume. So 26.5 grams divided by 13.38 milliliters. So putting that into your calculator, what are you going to get? If somebody would go ahead and try that while I switch over. Let's see the screen there. So 26.5, we're going to divide that by 13.38, and we get 1.98. So sig figs, this one has 3 significant figures, the 26.5. So we will have 1.98 grams per milliliter. Pretty straightforward. Our next question is an object that has a mass of 40 grams. So my mass is 40 grams. And notice how I've written out my variables, density, mass, and volume. That's very important for you guys to do that. My formula is density is mass over volume. So back to my question, an object with a mass of 40 grams, it displaces. So that when we put the nail into the graduated cylinder, we had a displacement of 0.8. Here we have 8.0 mils of water. Calculate the density of the substance. So my volume is 8.0 milliliters. Again, my formula density is equal to mass over volume. So 40 divided by 8.0 grams over milliliters. Well, 40 divided by 8 is 5. Don't need to do that in the calculator. Now, in terms of my significant figures, 40 doesn't have a decimal point. So 40 only has one significant figure. So I need to have one sig fig in my answer. So I'll just write down 5, and my unit is grams per milliliter. Okay. Next word problem. We're going to calculate the density of a block of wood that measures 2.50 centimeters on each side. So it's 2.50 centimeters on each side. And down there. So if we wanted to find the volume, it's going to be length times width times height. So 2.50 times 2.50 centimeters. I'll write it over here so we can see it. 2.50 centimeters. What's that equal to? So 2.5 times 2.5 times 2.5, 15.625. So that is 15.625. Now, in terms of multiplication, I should have 3 significant figures, but notice this isn't my final calculation, so I have to wait until the end for my final answer to determine my significant figures. So that is my volume, so it's 15.625 centimeters cubed because it's a regular shape. My mass is 8.27 grams. So what is my density? So density is equal to mass divided by volume. 8.27 grams divided by 15.625 centimeters cubed. So put that in your calculator. 8.27, divide that by 15.625. That gives you 0.52928. So final answer needs to have 3 significant figures, right? So the 8.27 has the least number. So my answer will be 0.529 grams per centimeter cubed. So again, every time you look at a number and you have to determine how many significant figures it has, that in essence is factoring in to your final answer. It has to match. So here we have a question where we have to find the volume of 8.67 grams of gold. So you might read this question and go, well, I only have one number, I only have mass. But you also have to your access to a chart that gives you the density. So we know that density is equal to mass over volume. So my density of gold is 19.30 grams per centimeter cubed. So here it is. My mass is equal to 8.67 grams. My volume is, I don't know what that is. So you can do this 2 ways. You can go ahead and plug these numbers into the formula as it is and then solve for the unknown, which is V. Personally, I like to do it ahead of time. So I'm going to move my V over to the right hand side. I'll cancel those out. And then my density, I'm going to have to divide by my density. So I'll divide by my density and I will divide by my density. So my answer, my formula is volume is equal to mass divided by density. So my mass is 8.67 grams. My density is 19.30 grams per centimeter cubed. And what we can see here is that our units are going to go ahead and cancel themselves out. So our grams and our grams will cancel out. And when we put this into the calculator, 8.67, and we are dividing that by 19.30, we're getting 0.449222. So our final answer, we have to look at how many significant figures we have. Well, our mass had 3, 8.67, and our density had 4. So we're going to go by the least number of sig figs. We have to have 3 significant figures. So that will be 0.449. Looking at our units, we know we're looking for volume. We saw that our 2 grams cancelled out. So our final answer will be centimeters cubed. So 0.449 centimeters cubed. Let me just write that a little bit bigger so you can see it. So 0.449 centimeters cubed with our 3 sig figs. So moving on to next calculation, and it is what is the mass of 9 mils of steel? And we're also asked you, is this going to float or sink in water? So we know that the density of water is equal to 1 gram per milliliter. So I have to find the mass is unknown. My 9.00 mils is going to be my volume. My density is provided on the right hand side. So my density of my steel is 7.90 grams per milliliter. And again, milliliter and centimeter cubed are used interchangeably. So here's our formula. So density is equal to mass over volume. I need to solve for my mass. So what I'm going to have to do is get rid of my volume. It's going to have to come up here, and that's real easy. So my mass is equal to my density times my volume. So my density is 7.90 grams per milliliter times my volume, which is 9.00 milliliters. So putting that in the calculator, 7.90 timesing that by 9.00 is going to give you 71.1. Now, 3 sig figs. 71.1. 71.1, and my mass is going to be grams. My mils are going to cancel out. So 71.1 grams. Is that greater or less than 1? Well, it's greater than 1, so therefore it is going to sink. So when you're given questions like this, as you're reading, you're underlining the numbers, you're using the units to determine, well, what is the variable that actually is being measured. And then from there, you're setting up your formula. I like to rearrange it at the beginning, and then I plug my numbers in. Putting the numbers into the calculator, I remind myself that the number that's displayed on the calculator is not my final answer. I have to make sure that I apply my significant figure rules. So, with that being said, I have another check for understanding quiz for you. And it's based on density calculations. And this time you're going to have to put a number in, so it's not a multiple choice. And when you put the number in, again, I have it set up so that it will tell you whether you got the correct number of sig figs or not. So ladies and gents, thanks so much for joining me here at o'kellychemistry.com. My name's Ivana, and hopefully I'll see you on Tuesday. Actually, I hope to see you on Thursday. Today is Tuesday. All right, good luck from me and Mr. Moleman.